This is section 5, definition of derivative. So in the last section, we talked about instantaneous rate of change and average rate of change, and all a derivative is another way of saying the instantaneous rate of change. Okay, it's just a term that we use and we will use for the rest of the year to describe the instantaneous rate of change. So you need to have those in mind every time you hear the word derivative. Okay, derivative, instantaneous rate of change. Another way we can talk about it is the slope of the tangent line. So a derivative is just the slope of the tangent line. So anytime I ask you what a derivative is, you need to have those two answers in your mind. Okay, every single time. Now, having said that, because we have already taken the instantaneous rate of change at a particular point, we know the formula. The derivative is just the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so nothing has changed. We're just giving it a new name. And we used this definition extensively when we were trying to find the instantaneous rate of change at a particular point, or the slope of the tangent line at a particular point. Now I'm going to show you how to find the general equation so that you can find the instantaneous rate of change, or the derivative, or the slope of the tangent line at any point you want, okay, based on the original graph. So before we do that, let's look at the notation. All of these, there's two notation, all of these. There's two notations that you really need to know. There are more, but we don't really cover those as we're doing calculus, at least at this level. Okay, there's no reason to really get into the other notations. The first one is f prime of x. Okay, that's this notation right here. The way you say that is f prime of x, not f apostrophe or something like that. Can't imagine what else you would come up with. It's f prime. That means the first derivative. And yes, there are more than one derivative, but that would just mean using this process again and again and again. So just don't worry about that quite as much yet. Another way you can write it is y prime or dy dx. And that's how you would say that fraction that you see right here. That said dy dx. It's not dy over dx, it is dy dx. And that'll be very important later on. Okay, that notation, that particular notation. All right, and that just tells you what you're taking the derivative of and with respect to what variable, because at certain points, you're not going to have just x. It could be dy dt. It could be dx dt, as the case may be. So just keep that in mind. So now, we are going to take the derivative using the limit definition, okay, and this is possibly going to take a while. So let's get started. We have the function x squared minus 3x plus 1. First, we want to find its general derivative equation. Because when I find the limit as h approaches 0 of f of x plus h minus f of x all over h, it's going to give me a general equation, as long as that's possible to simplify that. And for all of these problems, it will be. So we're going to do the same thing we did on the last problem, in the last section. We're just going to take the limit as h approaches 0 of f of x plus h minus f of x all over h. And remember, anytime you have something in parentheses, you're plugging it in for the x value in the original function. So this would give us f prime of x. So I'm going to take x plus h and plug it into my f of x every time I see x, which happens to be twice. So we're going to have the limit as h approaches 0 of x plus h squared minus 3 times x plus h plus 1 minus f of x, which is x squared minus 3x plus 1 all over h. Now this is going to take some simplification, right? The first term, x plus h squared, is going to have to be double distributed. So let me write it underneath. We get the limit as h approaches 0. X times x is x squared. X times h is xh, and that happens twice. So plus 2xh, and then h times h is h squared. Okay, and that's just double distributing. Now I'm going to distribute the negative 3, so we get negative 3x minus 3h plus 1. And now we're subtracting that entire equation, so we get negative x squared minus 3x plus 3x, we're distributing the negative, minus 1, and that is all over h. And so now we get to simplify. Okay, and what typically ends up happening, what should happen, is that anything without an h is going to cancel. And this is proven just by looking at this, right? We have x squared minus x squared, so those will cancel. We have negative 3x and positive 3x. Those cancel. We have positive 1 and negative 1, so those cancel. And so we end up with things with only h in the numerator, and that's going to be very important in this next step. So we have the limit as h approaches 0 of 2xh minus 3h plus h squared all over h. Now because there's an h in everything, I can pull out the h in the numerator. So we have the limit as h approaches 0 of h times, let's do 2x minus 3 plus h, which means that these h's cancel, and we're just finding the limit as h approaches 0 of 2x minus 3 plus h. Now we know that when you find the limit, you're taking the value of h and plugging it in because that's what it says. H is approaching 0. So if I plug in 0 for h, I just end up with 2x minus 3. That's the derivative. Now that I know what the derivative is, I can answer the other parts of the question. It says find f prime of 2, f prime of 0, and f prime of negative 1. When I find f prime of 2, it's positive 2, f prime of 2, I'm just taking 2 and plugging it into this equation. So it's going to be 2 times 2 minus 3, which is very simply 1. When I find f prime of 0, I'm plugging 0 in for x, so it's just negative 3. For f prime of negative 1, I'm plugging negative 1 in for x, so it's 2 times negative 1 minus 3, which is negative 5. That's a negative. I'm going to do the other parts of this problem in another video.